Hello and welcome to a new session with EdupediaWorld.com, your favorite portal for online education. This session we're going to continue with measures of dispersion. In the previous session we had seen what measure of dispersion is, and we continued with the first measure of dispersion, that is the range. We had seen that range was not a very suitable measure of dispersion due to the various drawbacks or limitations it had. Among them was that it was affected by extreme values. This session we shall continue with two more measures of dispersion, and they are the quartile deviation and the percentile deviation. We have already seen in the previous sessions what quartiles and percentiles are. Exactly, these are the partition values. We shall be using the value of quartile and the percentile to find the range. In other words, we will be eliminating the extreme values, the maximum and the minimum, which we use in the measurement of range. Rather, we will be using the third quartile and the first quartile, or any two percentile values. Alright, before taking up a numerical problem, let's understand how it is built. Let's start with interquartile range. Interquartile range is the absolute measure of dispersion given by the difference between the third quartile and the first quartile. We know that if we have a distribution, say from a certain minimum value to a maximum value, we can divide it. If we use quartiles, we can divide it into 4 parts by using Q2, Q1 and Q3. Now, to measure the range, we used to take the difference from the first data to the last. What we'll be doing now is we will be leaving the 25% from here and 25% from here. We shall take only the remaining 50% of the data from the middle, to find our range, or the interquartile range. Okay, so this is the middle 50% of the observation, and symbolically we can write interquartile range as Q3 minus Q1. From here we develop the quartile deviation, and it's simply half of the interquartile range. It's also called as semi-interquartile range, and symbolically we can write quartile deviation QD as Q3 minus Q1 divided by 2. And this of course is the absolute measure. The relative measure, that is the coefficient of quartile deviation, is given by Q3 minus Q1 by 2, that is the quartile deviation, divided by Q3 plus Q1 by 2, which simplifies to Q3 minus Q1 by Q3 plus Q1. Similarly, we can also develop the percentile deviation in the same manner, starting with interpercentile range, which is the absolute measure of dispersion, and this excludes I% of the observation on each end and includes the remaining 100 minus 2I% of the observation from the middle. To understand this, let's say we have data starting from the, let's say from 0 to 100. Now if I have to use the percentile deviation, what I do is I exclude some percentage from the beginning, let's say I, and I percentage from here. So out of total I remove 2i from both the sides and use the remaining 100 minus 2i percentage. To understand it in a better way, let's assume that I is equal to 10. Okay, now we know that percentile divides the data into 100 equal parts. So let's say we have from 0 up to 100. Okay, now if I is equal to 10, what I'm going to do is I'm going to remove the first 10 percentile of the data from the beginning and remaining 10 percentile from the end. Now if I remove 10 percentile from the end, it would mean that here I am at P90 and here I am at P10. In fact, 10 is the most common number used unless and until it is mentioned. So exactly, we will take the 80% of the numbers, 80% of the distribution, eliminating 10% from here, 10% from here. We are left with 80% of the data, which we will be using to find our interpercentile range, further developing into percentile deviation. Okay, clear? So it is symbolically P90 minus P10 if I is equal to 10. Yeah, hope that makes things clear. So symbolically we can write interpercentile range as P100 minus I, which in case if my I is 10, then P90 minus Pi, that is P10. And of course your I should be less than 50, which again I being more than 50 doesn't make any sense. And normally percentile range corresponds to I equals to 10, as I explained earlier. Further developing it into the percentile deviation, we just take half over this difference. So percentile deviation, which is also called a semi-interpercentile range, is given by P90 minus P10 divided by 2, and its coefficient, again in the same pattern as that of quartile deviation, could be written as P90 minus P10 divided by P90 plus P10. So that is the theoretical understanding of quartile and percentile deviations. Hope it's clear, but just to understand it in a better way, let's take and practice a few questions. Alright, so here we have a data giving the age of a certain number of students and the number of students in each class. So let's find out the interquartile range, interpercentile range, quartile deviation, percentile deviation, and finally the coefficients of quartile deviation and percentile deviation for this problem. Of course, to get the quartile deviation or percentile deviation, we will have to first find out the Q1 and Q3 values, at the same time P10 and P90 values. So what do we do for that? Exactly, we first need to find the cumulative frequency here. So let's continue in the same way, and yeah, so the total is n equals 60 Well, to understand the working of finding out the quartile and the percentile deviation, you can refer to our video on partition values. Alright, so here n is equal to 60, and we know that quartile divides the data into 4 equal parts. Therefore, to find the Q1 value, I'll have to divide this n by 4. So n here will be divided n by 4. N by 4 will be equal to 15, and to find Q3 I need to find 3n by 4. So 3n by 4 will be equal to n by 4 multiplied by 3, which is equal to 45. So my Q1 corresponds to n by 4, which is 15. Now we see that the 15th data here corresponds to this class. So this will be, let me write here, Q1, and 45 corresponds to this class. Therefore this would give me my Q3. So my Q1 equals 17 and Q3 equals 19. Okay. Well, once I have got the Q1 and Q3 values, I straight away for interquartile range, interquartile range will simply be equal to the difference between these two. So it is 19 minus 17. And what about quartile deviation? Quartile deviation will simply be the value divided by 2. So quartile deviation here is 1. And the coefficient of quartile deviation, let me write it in short, coefficient of quartile deviation will be equal to the quartile, or let me do it fully, it's Q3 minus Q1, which is 2, divided by Q3 plus Q1, which is 0.0556. Okay. In the same way, we can find the percentile deviations as well. So to find, now we know that the percentile divides the data into 100 equal parts. To find the 10th percentile, what I need to do is find the 10n by 100 value. Okay, so 10n by 100, n is 60, so will be 10 multiplied by n divided by 100. That gives me 6. Now 6 corresponds to this class here because the cumulative frequency here is 10, so 6 corresponds to this class. We have our P10 equals 16. Okay, let me give them some color. Okay, this, say, shade of blue for this, and let me give a shade of well, green for this, Q1 and Q3. Okay, and similarly to find the 90th quartile, I'll have to do 90n by 100. Okay, so that will be 90 multiplied by n divided by 100, and that gives me 54, which corresponds to this class. Okay, so again let me give a shade of blue to this. Yeah, so my P90 is 20. Well, so now I have my percentile deviation also, so let me do that here. Interpercentile range, and that will be equal to the difference between P90 and P10. That's 4. Percentile deviation is half of it, so it will be this number divided by 2, and finally the coefficient of percentile deviation, and that's going to be P90 minus P10 divided by P90 plus P10. Okay, and that is 0.111. Alright, so this is how we calculate the quartile and percentile deviations. Very simple. If you know how to calculate the quartile and percentile values, finding their deviations is trivial. Alright, now just to have some more practice, you can take up another question, and this time we have class intervals. Now the treatment is the same whether you have class intervals or you have simple data. The treatment for calculation of quartile and percentile deviations are the same. What differs is the calculation of the quartile and the percentiles themselves. Now in this case, alright, so just for practice, as usual, you can stop me for a while and try doing it yourself, and then we can do it together. Alright, so let's do it. Now as usual, we will have to first find the the cumulative frequency here. The cumulative frequency table, and then we need to calculate the value of n, which we see is equal to 80. Okay, so once we have got the value of n, we can straight away now proceed to find our Q1, Q3, P10 and P90. Okay, so now for Q1, what do? We find n by 4. And what is n by 4 here? It's n divided by 4, which is 20. Let me just put them in order. Alright. So n by 4 happens to be 20, and that corresponds to this class. Okay, again let me give a color. Then we need 3n by 4, 3n by 4, that's simply equal to 3 multiplied by n divided by 4. That happens to be 60, which corresponds to this class. Okay, so here you have your Q1 and here you have your Q3. Now this time it's a class interval, so we will have to use the formula to find the to find the first quartile and third quartile. And if you recollect, the formula is lower value of the class, which is 15 in this case, plus n by 4, because we are calculating q1, so let me put it in parenthesis. N is 60 by 4, which is 20, n by 4 minus cumulative frequency before the class, which is 18, okay, and then that's divided by the frequency of the class, which is 15, okay, and the whole thing is multiplied by your value of h, which in this case is 2. Okay, so that's the value of q1. Similarly, to find q3, the lower value is 19 plus n by 3, n by 4, which is 60, minus cumulative frequency before the class, which is 53, divided by frequency of the class, which is 12, and then the whole thing multiplied by h, which is 2, and that gives me 20.1667. okay, so that's my value of q3. Next, let's find out the value of p10 and p90. For that I need 10 n by 100, which is equals 10 multiplied by n by 100, that is 8, and then I need 90 n by 100, which is equal to 90 multiplied by 80 divided by 100, and that's equal to 72. So my p10th class falls here, p10, and 72 falls here, so this is my p90th class. Yeah, so let me give them a different color just to differentiate. Okay, so now let's calculate again in the same way. So your lower value of the class is 11 plus the value here is 8, so 8 minus, now what is the cumulative frequency before this class? Well, we don't have any, therefore we'll put it as 0, and this will be divided by the frequency of the class, which again is 8, and the whole thing would be multiplied by 2, so that gives us 13. So p10 is equal to 13, and finally p90, the lower value is 21 plus 72 minus 65 divided by 11 multiplied by 2. Okay, there's something to check in the formula, just let me have a look. 21 plus 72 minus 65 into, okay, this is not into, this is divided by 11 into 2. Yeah, now hopefully, yeah, so now it's 22.27. Well, once we have got the p10 and p90 and q1 and q3 values, I can easily find the interquartile range. Interquartile range will be equal to q3 minus q1, then quartile deviation will be equal to this value divided by 2, and then finally coefficient of quartile deviation will be equal to Q3 minus Q1 divided by Q3 plus Q1. Okay, so that's the coefficient. Similarly for percentile, let me do them here. This is for quartile and this is for percentile. Okay, for percentile deviation the value would be P90 minus P10 its coefficient quartile percentile deviation would be this value divided by 2, and then finally the coefficient would be P90 minus P10 divided by P90 plus P10. Alright, so hope this is clear, and this is the simple treatment which we have for quartile and percentile deviation. And we realize that although we have overcome some of the drawbacks of the simple range, that is, we are not using the extreme values. So if there is an extreme value by chance, of course we can escape that, but then again the other drawbacks are not eliminated. We are not using all the numbers, we are just using certain selected numbers to find the range, and we do not have much of mathematical treatment. Therefore again this is not the most suitable measures of dispersion, but again is one of the measures of dispersion which we needed to know. And the advantage with this is that it is again easy to calculate and easy to comprehend. We shall be further seeing the next types of measures of dispersion, which are the mean deviation and standard deviation, in the subsequent sessions. Keep watching Edupedia World videos. Thank you.